Hello and welcome to a new chapter of our interactive music series. This time, we're diving deeper into the world of sound with Spectrogram. As always, we begin our adventure by opening our web browser and typing Chrome Music Lab into the search bar. From the search results that appear, we click the Chrome Music Lab link to reach the main page of Google's creative music platform. Scrolling down the homepage, we find the Spectrogram tool among the various fascinating experiments, which visualizes the frequencies of sound. Let's click on it. Here is the Spectrogram interface. This black screen is essentially a canvas where we can draw a picture of sound. Along the bottom, there's a row of icons representing different sound sources. First, let's find out what it does. By clicking the question mark in the top right, we learn that a spectrogram is a picture of sound. It shows us the frequencies, from low to high, and how those frequencies change over time. Let's start by trying the microphone icon. This mode visualizes the sounds around you or your own voice. As you speak or make a noise, you can see the trace your sound waves leave on the screen. Now, let's switch to the drawing mode by clicking the finger icon. Here, you can draw your own sound by moving your finger or mouse across the screen. By drawing different shapes, you can create completely unique sounds. Now, let's examine the preset sound sources. We'll select the flute icon. Listen, on the spectrogram, you can clearly see the clean, distinct fundamental frequency of the flute and its fainter harmonics or overtones above it. Our next instrument is the harp. When the harp plays, we can see the visual representation of the arpeggios formed by notes being played one after another quickly. The vibration of each string leaves its own unique trace on the spectrogram. The next icon is a whistling sound. You can see how pure the sound produced by whistling is, concentrated in a single frequency band. The rises and falls in the melody correspond perfectly with the movement of the bright line on the spectrogram. Now, let's listen to a powerful brass instrument, the trombone. The trombone's characteristic slides and rich harmonic structure create a more complex and layered visual spectacle on the screen. It's rhythm time. We're clicking the drum machine icon. The sounds of percussive instruments like the kick, snare, and hi-hats appear as short, sudden, vertical bursts of energy on the spectrogram. Low-end kicks appear at the bottom, while high-frequency cymbals are visible at the top. A sound from nature, birds chirping. Thanks to this visualization, we can clearly understand how complex and rapid the frequency changes in birdsongs are. Each chirp creates a unique pattern on the screen. Let's get a bit nostalgic and listen to the sound of a dial-up modem. You can see that this iconic digital sound consists of signals shifting between specific frequencies and how visually regular this pattern is. Finally, the sound of a wine glass. The magical, continuous, and resonant sound produced by rubbing a finger around the rim of a glass is visualized here, showing how closely it resembles a pure sine wave. Now, let's return to the drawing mode. You can add a vibrato effect to the sound by drawing wavy shapes, not just straight lines. Every movement of your hand is instantly transformed into sound. This is one of the most fundamental and fun ways to synthesize sound. You can compare the visual fingerprints of different sound sources by listening to them again. Every sound has its own unique frequency structure and identity, and that's how simple and fascinating the visible form of sound is. With the spectrogram experiment, we've explored the science behind sound. If you enjoyed this fun experiment and would like to see more interactive content like this to give you new insights, check out what else we have on our channel. Don't forget to subscribe and click the bell to get notifications for new videos. See you again soon, and thanks for watching.